Section 1411 talks about thiols and sulfides. So a thiol has this type of functional group. So it's analogous to an alcohol. So if we have an alcohol, we know we number the longest carbon chain so that the OH has priority. So this is called 1-butanol or butan-1-ol. I prefer to name it 1-butanol because it sounds less awkward and it's actually conversational friendly, 1-butanol. Now the thiol, we would name it, exactly the same, except it would be ending with thiol instead of ol. So this is 1-butane thiol. I guess the only difference is you kind of have the E from the butane because you have that thiol there, which begins with a consonant T. So that's 1-butane thiol. Sulfides, well, we'll get into that, I guess. But sulfur is an extremely good nucleophile. So one way to prepare thiols is to take an alkyl halide and treat it with sodium hydrogen sulfide, or NaSH, I like to say, and this will create a thiol, okay? Thiols are rather stinky and unpleasant to work with. The reaction is occurring by SN2, so if you have something like this, and we treat this with sodium hydrogen sulfide, this displaces the leaving group, the bromide, by attacking from the opposite side of the molecule. Here it would attack from the top side to give you the cis thiol, okay? That cyclopentane has two groups on a wedge, so we call that cis. Now, thiols are extremely stinky, as I mentioned. A skunk produces without the methyl group there. This guy here, it's a butene thiol, okay? So we've got, instead of butane thiol, as I mentioned before, this is butene thiol. So this is butene thiol. And as we know, if a skunk sprays your dog or you hit a skunk while you're driving, it can be a tremendous stench that lingers for quite a long time. Now, one way to remove the odor of this is to make a mixture of water, sodium bicarbonate, and hydrogen peroxide, and spray your car underneath everything you can possibly see. And this will oxidize the thiol to the corresponding sulfonic acid. So that's a sulfonic acid functional group. That's odorless, and you and your family members would be thankful for that. And this is quite pungent. We'll just say it has a stench, okay? So that's one way to oxidize thiols. Now, if you have a molecule that is a thiol to begin with, and you treat this with a base followed by, like say methyl bromide or something like this, you can convert this to a sulfide, okay? That mechanism there is also an SN2 reaction. Thiol becomes deprotonated. You make the thiolate, and that can attack bromomethane, thereby kicking off the leaving group to give you what's called a sulfide, okay? So if that was an oxygen in the middle of the molecule, we would call that an ether. Here we call this a sulfide. The sulfides also can be oxidized. Many different mild oxidizing agents, from hydrogen peroxide and bleach, things like sodium periodate and so on and so forth, can be used. This can be oxidized to the sulfone, for example, the sulfoxide, I'm sorry. I'll put in the lone pairs here. Okay, sulfoxide. Or it can go on to react further to form a sulfone. Sulfoxide sulfones show up a bit in pharmaceutical compounds, so you can kind of see them once in a while. That's all I wanted to mention about that, just so you'd kind of have a preview of that. Sulfur and oxygen, again, are in the same group of the periodic table. Oxygen's a nucleophile, can attack things in a Williamson ether synthesis, and so can sulfur. That's all I wanted to mention. In my course, you don't need to memorize the names or all these different reactions, but I just wanted to give you a brief preview. Thanks for watching.